Hello and welcome back to my channel. Today we're going to be talking about Taylor and Maclaurin series. So we've been talking about Taylor polynomials and now we're going to talk about a series. So the big difference between a Taylor polynomial and a Taylor series is that the Taylor series is going to become that function that it's representing. So with the Taylor polynomial, we're going to get that f of c plus f prime of c times x minus c to the first power plus the second derivative at c times x minus c squared over 2 factorial plus, and all of those terms in between until we get to the nth derivative at c of x minus c to the n power, all divided by n factorial. So this right here is our Taylor polynomial. So this is the polynomial version of it. It has an end. The Taylor series version of this is going to look exactly the same. We get f of c plus f prime of c times x minus c plus f double prime of c times x minus c squared over 2 factorial all the way till we get, oh, I don't want to use f's. What am I doing? We're going to use g's. So that way it's a different function. All the way till we get to the nth derivative of g at whatever value we're looking at times x minus c to the n divided by n factorial. And right now you're thinking the only thing we've done is change the f to a g, and so it doesn't match the original function. You're right. But the big difference here is this. We are now adding a plus dot dot dot. So we're going on forever. We're going into the infinite number of terms. So Taylor series goes on forever while a Taylor polynomial has a specific end. So we have 3 really, really important Taylor series. They are so important that it would be great to know without having to make them up on the spot. We can use any variable, but we use x because it's going to be easy for us. But these are the ones that we want to know. So e to the x we kind of talked about when we started learning about Taylor polynomials. I know my first term is going to be 1 because f of whatever our value is our value. So if it's centered at 0, we get this. Our second term would be x because e to the 0 power is 1 again, so 1 times all of this stuff. And then we keep going, and we get this pattern, x squared over 2 factorial plus x cubed over 3 factorial, and that continues on until we get x to the n over n factorial. So one thing that we want to talk about really quick is when we look at a Taylor series, this nth term is also known as the general term. So sometimes we're asked about the general term, and that's what they mean. They want that nth term. Okay, so the next one we're going to look at is sine. Sine and cosine kind of go together, but because sine and cosine at certain values go to 0, we get rid of the non-zero terms. So sine's Taylor series is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus 7 x to the 7th over 7 factorial plus our nth term. One of the things you're going to notice is that all of our exponents and all of our factorials are odd, and they start at 1 and go on. We're also alternating, so I need an alternating piece, and then I need an x to an odd number. Our automatic way to do an odd number is 2 to the n plus, or 2n plus 1. So 2 times a number and then add 1 to it. That's always going to give us an odd number. And because our exponent matches our factorial, we're going to make that our parentheses for our factorial. And it's a series, so it goes on forever. You're going to notice cosine is exactly the same, but a little bit off. So our first term is going to be 1. Then we're going to subtract x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And that goes on until we get to our general term. This also has an alternating piece, so we're going to use -1 to the n. This time our exponent and our factorial are even numbers. So instead of 2n plus 1, we're going to go with 2n. So no matter what we put in, we multiply by 2, it becomes even. And it's a series, so it goes on forever. So these are the ones that are the most important Taylor series. They're all ones that are x to a power divided by a factorial of that same power. It's just, is it 1x x squared divided by 2 factorial, 3x cubed divided by 3 factorial, or is it kind of skipping and alternating? Okay, so our first problem here, find a power series for the function f, where f of x is equal to e to the x minus 1. So a power series is another way to talk about a Taylor series. They're called power series because we're dealing with x to a power. So the first thing that we want to remind ourselves when we're looking at things, centered at 0 means that we don't need to change the x's at all in our form. One of the things that we have to remind ourselves is e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. And that works until we get x to the n over n factorial, and then it keeps going on forever. But what we want is e to the x minus x minus 1. So what we're going to do is we're going to put in e to the x first. So everything we just wrote, I'm going to write again. Oh, I can't forget the infinite part. Okay, but we still need this minus x and minus 1. So I'm going to add that on to the n, minus x minus 1. Well, if I look at my function, I have a 1 and a minus 1, so those are going to cancel out. I have an x and a minus x, so those are going to cancel out. So our answer is going to be x squared over 2 factorial plus x cubed over 3 factorial plus everything in between up until x to the n over n factorial, and go on forever. And this would be our answer. So the answer to that question is literally this. So we're just using this power series to kind of do something else with it.